Okay guys, so this is your boot camp about alcohols. The first one is about why alcohols have their boiling point. And I've also drawn a diagram underneath to show what you would draw if asked to show an example of this hydrogen bonding. This of course is in ethanol. They could give you any molecule. It could be propanol, butanol, whatever. Of course, the length of the carbon chain doesn't matter. It's really all the OH that does anything. The green notes in the bottom are the really important bits because these are the common mistakes students tend to always make. So they're the bits to try and remember the most. Okay, so 5 minutes. Look, cover, right, check, repeat, 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 repeat. Off we go. Three minutes gone, only 2 minutes left. You'll notice in the explanation for boiling point, when we talk about why it has a high boiling point, we always mention about the energy required to break it. In general, whenever you're talking about the boiling point, it's all about the energy required to break either the forces or the bonds. Hey Sarah, how's it going? Hi there. That's cool, yeah, definitely. Oh, okay, yeah. Oh, good. Yeah, so usually it's Thursday when I would usually do it. So like, would Ahmed do 7:30 on Thursday, or is that not a good time? Okay. Yep. Okay. Uh, sure. No, it'll probably usually be fine. There might be like 1 or 2 Saturdays where I'm not in Brighton, is the only thing. But usually that would be fine. We could just do it on kind of like a week by week basis and kind of see how it goes. Yeah. Okay. Mhm. Okay guys, and here is the second slide. This is oxidation. This is of primary alcohols. There's quite a bit here, so I'm going to leave this on for 6 or 7 minutes. We've got our primary alcohol being partially oxidized to give us an aldehyde and water. The second bit down is our our aldehyde being oxidized further into a carboxylic acid. You'll notice there's no waters given off there. Also, the last bit, the third bit down there, what I've shown is both of those steps combined together. So that's why there's two O's in brackets there, two oxidations happening at once. And that will give us a carboxylic acid plus the water from the first step. So there's only one water given off there. So 5 minutes, well, let's say 6 minutes for this one, as it's quite a big one. Off we go. halfway through now, guys? These types of questions crop up all the time. An oxidation of alcohols question is probably one of the most common questions in the exam, so definitely worth learning. One more minute to go, guys. Try and get out another 2 times. Okay, guys, and on to the next one. So this is secondary and tertiary alcohols. Obviously tertiary cannot oxidise, so there's not much to remember there apart from they don't oxidise. So 5 minutes, off we go. 1 minute down, 4 to go. One of the common mistakes with this is on the ketone, people put a hydrogen on the middle carbon, which of course would give that carbon 5 bonds. So really watch out for that. Obviously carbon should only ever have 4 bonds. One more minute left. Okie dokie guys, and on to the next one. So this is just some extra little bits and bobs to remember about oxidation. There's lots of different ways of writing acidified potassium dichromate, and you can mix and match. So you could have H plus / Cr2O7 2-, for example. So these are all the little bits which gets you those extra few marks in the oxidation style question. 5 more minutes. Look, cover, write, check, repeat. Off we go. The Liebig condenser, by the way, is that hollow tube with a jacket of water around it, which acts to cool your gases into a liquid and condense them. Okay, 2 more minutes, guys. So as with all this bootcamp stuff, if of course you don't understand anything, don't just blindly write it down, actually do find out what it means. So you can always come to a subject extension, which is every lunchtime or usually the hour before lunch, or you can stay back and see your teacher at the end of a lesson, providing of course you don't have or they don't have another lesson straight after. So always try and find out about the work you're not sure about. 30 more seconds, try and get down one more time. Okay, first slide here, there's actually 2 more slides after this. Alcohols is quite a big topic, so there's quite a few bits to do on it. This is what the equipment for distillation and reflux look like. So we've got this Liebig condenser there, which is a hollow tube surrounded by a jacket of cold water, which will cause condensation. So, distillation, which gives us partial oxidation, and reflux, which gives us full or complete oxidation. 5 minutes, off we go. Three minutes down, 2 to go. Okie dokie. So the last two slides are about the two different ways of making alcohols. This first slide is about fermentation. So C6H12O6 is glucose. If you was fermenting some wine, you'd get that from grapes. If you was fermenting some cider, you'd get it from apples or pears. Yeah, and then that will give you your ethanol plus carbon dioxide as a waste product. Although there are actually some uses we can use the carbon dioxide for, thus increasing the atom economy. Some advantages there, so it's made from renewable resources, which is the glucose, and then just three conditions: yeast, which contains the enzyme zymase, a temperature. If you used to say any temperature between there, you'd get the mark, so I would just say 30 degrees and then you'd be fine. And then anaerobic conditions. The reason we need anaerobic conditions is because the yeast only does this reaction when there's no oxygen. If there was oxygen, it wouldn't bother doing fermentation, it would just do respiration instead to get its energy. So, 5 minutes guys, off we go. One of the disadvantages, which isn't on here but maybe is worth remembering, is that with fermentation you can get alcohol much more than about 14 or 15%, which is why unless you have fortified wine, wine can't get much more than 14 or 15%. That's because if you do get that, then the alcohol that the yeast has made becomes toxic for it and kills it. So the yeast is basically, getting too drunk on its own alcohol and dying, basically. So one of the disadvantages you could mention is that you can't get much more than 14% pure alcohol-ish. Thirty more seconds, guys. Try and get down one more time. And obviously always be trying to actually take it in, trying to remember it, get it stuck in that grey matter. Okay guys, and our final one, this is the second way of making an alcohol. This is using the hydration of ethene. So the advantage of this is it's 100% atom economy because your only product is your alcohol. Disadvantages is that the high temperatures and pressures are expensive and dangerous. So don't just say it is expensive and dangerous, don't ever say it. That's the banned word in chemistry. We need to say the high temperatures and pressures. Conditions here are phosphoric acid catalyst, H3PO4, 300 degrees C and 60 atmospheres. So 5 minutes guys, off we go. It has been a particularly long boot camp this time, so well done for getting this far, and with 3 more minutes to go then we're done, and this really will help in the exams. One more minute left guys, you've done really well. Okay, so that is our alcohols bootcamp done. Well done for that, guys. Really good work. Don't forget to bring all your scrap pieces of paper so we can check on that. And we'll see you next time. Have a good week.